Today on a bench we have this very crumpled up box containing one of these very strange looking LED bulbs you can find all over Aliexpress. That is kind of like a flower, I guess, that you can sort of just open up. And so here's the listing I bought it from. Don't let the low price of €1 fool you. There is always a shipping fee higher than the actual bulb. I didn't actually need this bulb, I just wanted to see how well it was constructed, so I bought it. I paid, I think, €3.62 for it, and here it is. It claims it is 28 watts. It doesn't say how many lumens it produces, but the general rule for these LED bulbs is 100 lumens per watt. So if this is a 28 watt bulb, this would be a 2800 lumen bulb, which is absolute nonsense. I did actually test it against a normal bulb. This is a 6500 Kelvin bulb, and what I compared it with was a 2700 Kelvin bulb. The reason for that is because when I was buying this thing, I couldn't actually choose the color temperature, and all of the bulbs in my house are 2700 Kelvins. The LED chips after about an hour were running at around 100 degrees Celsius, both in the middle and on the flaps, or whatever these things are called. Okay, with that out of the way, let's dig into this thing. Okay, so here are all the parts of the bulb. As you can see, all of these LEDs are actually in series, which is what one would expect, because they always are inside of these LEDs. Okay, so first thing I would like to do is do a power measurement, because I unfortunately don't have a proper power measurement device. I could just measure voltage and current, but because this LED more than likely doesn't have a good power factor, it will throw the measurement way off. So what I thought I might do is I will measure the voltage across the LEDs and the current across the LEDs to see how much power the driver is actually pumping into these LEDs to run them so hot. There, I look. There, I look. It worked. We go to DC 200, back to milliamps, and then we will cut one of the wires, sharpen it. Oh, though it is an actual silicon wire, which is something I didn't expect. Okay, we are on DC, and we'll put this to DC. Plug it in and power. It's pushing 118 milliamps through the LEDs. Could this thing actually be drawing 20 watts? No way. It's making interference noises with my computer speakers. Watch me blow this up. 116 volts, 116 milliamps. So that would be 116 volts times 0.116. Oh god damn, this thing is actually drawing about 13.5 watts. That's actually quite a bit more than I expected. But it is running really hot. Though when you think about it, a standard light bulb has this much surface area to cool it down, which isn't a lot. And this thing has this, and this. And it's still running very hot, but it could in theory deal with 13 watts of power. But god damn, I don't think these diodes are rated for 100 and... let's unplug it first. I don't think these diodes are rated for 100 milliamps. These things are typically rated for about 30 milliamps. A typical LED drives similar type of LED with 30 milliamps. And this thing is pushing 116 milliamps through them, which is a lot. So I don't think this... it did work. I did run it for 2 days straight and it did not fail, but I don't think it would last for much longer, seeing how much power it is pushing through the LEDs. Now let's move this death cable out of the way. Yeah. So here's the little driver board. So we have mains going straight into the bridge rectifier, not even a resistor or not there isn't any kind of fuse, not even a sad excuse of a fuse that Chinese like to use, which is literally just a thin track that blows up in an event of short circuit. In this case, it is literally a wire soldered straight into the bridge rectifier. So no, and this wire right here is, I think, a bit too thick to be used as a fuse. Though these are proper silicon wires, which I'll give them that. From the bridge rectifier, it goes into the 4.7 microfarad 400 volts capacitor, which is branded by Chongx. That's hilarious. So typically in cheap products you will see a brand named Changx, which is even that is a cheap Chinese manufacturer, and they are actually not ripping someone reputable like Nippon Chemicon, Rubicon, or whoever the heck. They are ripping the cheap Chinese manufacturer, which is hilarious. Okay, so after the capacitor, it goes into the this is a buck regulator chip. Can I focus to see what it is? A DP, and the current sensing resistor is 2R55, so it's a 2.55 ohm current sensing resistor. And then it goes to this little thing that looks like a transformer, but it is actually an inductor. It has 4 mounting points, but they are connected together, so it actually has only 2 pins, which is typical for an inductor. Okay, let's try this website. Now it's downloading a virus. That's nice. Okay, this looks a bit more promising. This is a logo that was on the chip, so I guess here is the data sheet. This is the actual schematic of the IC of the little driver board, except they skimped out on this capacitor right here. There is absolutely no filtering on the output of the regulator whatsoever. So that's the schematic. The chip does the regulation by regulating the voltage over the current setting resistor. So it wants to maintain 300 millivolts across the resistor. So if you decrease the resistor value, the chip will push more power to the LEDs because across a lower value resistor you need higher current to achieve 300 millivolts. So we can calculate the constant current output just by dividing 300 millivolts with the resistor, which is 2.55 milliamps. So let's do that. So that will be 0.3 for 300 millivolts divided by 2.55, and we get 117 milliamps. 0.117 amps or 117 milliamps, which is correct according to what we measured. In theory, I could just increase the value of this resistor to make it run a bit less hot, so it hopefully lasts a bit longer, because it is fairly bright, and the fact it can handle 13 watts of output is quite impressive. So yeah, that's it for this light bulb. Here are all the parts to it, and I will put it together. So yeah, that would be it for this dodgy light bulb. It's a fairly simple and straightforward construction, except the plastic. The plastics are fairly complex for absolutely no reason, but I mean, you need to stand out somehow in order to sell a product in this modern day and age. So I can kind of understand it. So I only have two concerns with this LED. So first thing is there is absolutely no fuse or fusible resistor, so in case something happens, something shorts out, it could start a fire, so that's something that needs rectification. And the other thing is they are pushing way too much current through these small LEDs. Now you might think that I will be concerned about the high temperature of the high running temperature of this LED, but running LEDs at over 100 degrees Celsius is fairly normal, unfortunately, and it is a reason why many modern TVs fail and why these cheap LED bulbs, while even these mainstream LED bulbs fail so quickly, as you can see. This one ran so hot that it literally discolored the plastic. So yeah, so no fuse and way too much current for these tiny LEDs, and the rest is, I guess, fine. I didn't notice any issues with color rendering. I'd say it's around 80. I don't like the 6500 Kelvin color temperature, but that's just due to personal preference. Other than that, I'd say it's fine.